But welcome here, everyone. My name is Arpteg. I'm glad to be here the second year in a row. The last year got a lot of feedback afterwards, so please don't hesitate to reach out afterwards if you want to know more about what I'm talking about. So I'm going to talk about specifically what's happened in AI the recent year. And as usual, a lot has happened. But there is one thing that is a bit surprising about this year in 2018, and that is the number of investments that we have seen coming. So nowadays, it's not just these large technology companies, the Facebook, the Googles, the Amazons of the world, that are investing millions and billions in these techniques and making huge profits by doing so, but also politicians are now starting to make significant investments in Europe and also in Sweden. So I'm going to try to, for one, talk about what these investments are, but also a bit why this is happening right now, and trying to give my view of what artificial intelligence is. And I'm going to do that by trying to give a set of very concrete examples of how industry make use of AI, partly from Peltarion, where I work today, but also from Spotify, where I worked for a number of years, and some other examples that really demonstrates what's possible to do today with the latest type of AI techniques. If you have any questions, I'm happy to take them. I think it's more fun for me and hopefully for you as well if we have a bit of interactive discussion. So just raise your hand if you have anything I say is unclear, and we try to make that happen. Sounds good? Awesome. So let me just very quickly give an introduction to what I think AI is. There has been a number of definitions of that, and the history of AI goes back to the 1950s. And it was already back in 1956 where John McCarthy first coined the term, saying, AI is the science and engineering of building intelligent machines. And I think that's a really nice way to, for one, understand it's both about understanding how the algorithms work, but also about the engineering skills necessary to actually build an intelligent system that can make use of these techniques. But in the beginning, in the 1960s and 70s, people believed that you could simply write a computer program to make it intelligent. So, for example, in 1964, they had a so-called Georgetown experiment where they wrote a program that could translate 60 sentences from English to Russian. And they were so happy with these results and said, in 5 years, we are going to have a system that can translate any sentence between any language. And we all know that didn't happen. And it turned out to be much more difficult than people imagined to actually write these kind of intelligent systems. But a number of things has happened over the years. So in, for example, 1980s, a new type of algorithms started to come about that made it possible to make a system intelligent by feeding data into it. So instead of writing computer code, you could feed data into a system and it could learn to make predictions given that data. So in one way you can see it as it automates the process of building these intelligent machines. And these are techniques that I've used a lot in the early years. I've been working and doing research in AI for 20 years. And when using these traditional machine learning techniques, they are great, but there is a big problem, and that is you have to be really careful how you transform the data, how you do this feature engineering work. If you don't do that properly, the algorithm making the prediction will not work. So you have to be really, really careful, and you had to spend a lot of time programming the data transformation task, doing the feature engineering. What's happened more recently in the last 5-10 years is new techniques has come about that make it possible not only to learn to make the predictions, but also automatically learn how to represent the data, how to do this data transformation by learning from data. So you not only learn to make the prediction, but you also learn how to represent it. Does that make sense? That also means that you can use different type of data, not just tabular data, but you can also use images, audio, text, and feed that directly into the system, and it learns to transform, for example, a picture into a set of layers, into the eyes and the edges and so forth, to later make the proper classification. And that has led to a significant increase in the ability of simply building intelligent machines. So this recent revolution in building intelligent systems is not only because of algorithmic improvements. That is, of course, important, but if we look through the latest breakthroughs we've seen in AI, many of them, when you actually invent the algorithm and the time until the breakthrough happened, is in average about 18 years. So a lot of the deep learning techniques we have today is based on algorithms from the 90s and earlier. But if we instead look at in data and see, okay, when a certain breakthrough happens, and see when did the data for that breakthrough become available, in average it's around 3 years suddenly. So the data is super important. If we don't have the data, it doesn't matter if we have the best algorithms in the world. We need to also have good data. And that means, not only the big data we are seeing today, the IoT data that we are seeing, but also research data sets like ImageNet that allows us to learn how to make use of these techniques in the best way. In addition to that, we have seen a significant increase in computational power. So moving from CPUs to GPUs to TPUs to FPGAs, that had led to like a 100-fold increase in computational power that made it possible to process all this data and use very large models and be able to train them efficiently. We have seen some increase in tooling as well around this latest type of AI, but that is still a problem that is causing a lot of companies to fail when they try these techniques. So the tooling has been improved, but there is a lot of immature tooling still around for how to build these type of systems. This is actually what we at Peltarion is working hard to improve. Here is just a quote trying to signify how important this new wave of AI is, and this is the founder of Google saying it's the most significant development in his lifetime. We can take another interesting chart from NVIDIA, the manufacturer of these GPU cards that they mainly use today. And when people started using these GPU cards, not just for playing games, but actually for deep learning, you saw a 3-fold in market cap over 2016. Here's another quote from the CEO of Microsoft, and I really like this quote because it really frames that it's when you work together, humans and machines, that we get the best benefit of these type of techniques. So, fighting the social challenges we have, like poverty, disease, and so forth. We have an example from Peltarion as well, where we try to identify wheat rust and diseases in crop fields in Ethiopia, and in that way can prevent hunger and other catastrophes happening there. I will talk a bit more about that shortly. Here is a last quote from the CEO of Google or Alphabet, and they in 2016 made this big transformation from being a mobile-first company to becoming AI-first. And that partly means that you start to make use of AI in all your products and services and different parts of that. And just to give an example, I upgraded my phone recently, a couple of weeks ago, to Android 9, this Pi version. And if you look at the new features it has in Android 9, it's adaptive battery, adaptive brightness, and predictive app actions. So all these different parts of a product are starting to make use of AI and become predictive in some sense. You are transforming problems that wasn't before predictive into making use of AI and therefore becoming predictive. And that is what happened when companies start to become AI first. So that was a very quick introduction to a bit what's happened in history. And I'm going to focus a bit now more on these investment that I spoke of. And people say now that AI is going to be this the big next industrial revolution. And we wish, of course, that Sweden and the Nordics were in front of it. But when we actually look at the number of publications made by different countries, this is during 2016, we can see the two leading nations, of course, being China and United States. And this was very apparent when we had the big AI conferences here in Stockholm this summer with ICML and ISHKAI. So it was very apparent that these two are leading right now in the field. And Sweden is, as you see, a small part here. And even if we look at publication per capita, we are still in Sweden compared to our neighbors in Nordics, like Denmark and Finland, about half number of publications. And that's a bit sad, and something needs to be done about that. Here is another article from Financial Times from this summer, basically saying the same thing. We in Europe are left playing catch up with the rest of the world, and they gave some numbers comparing private and other investments in Asia, America, and Europe. They also mentioned Peltarion, by the way, so that can be interesting for you if you want to see more. But we have some positive initiatives being made. So if we look in Europe, for example, we have UK that in April this year, 2018, made a big announcement saying they're going to invest about 1 billion euros into increasing the application of AI in UK and making UK leading in AI. We saw a similar action in France, and Macron spoke also about 1 billion euros being invested to make France the leading AI nation and building up an AI hub and so forth. Germany as well, and Merkel spoke about that. At the same time, all of this is happening in April in 2018 for some weird reason. But just a week before Macron's talk, Merkel also spoke about Germany's new investment in AI. They didn't really specify a number, but Germany is very strong in automotive and other sectors, and it's expected to be around 1 billion euros for them as well. Another country is Finland, that actually has made a significant investment and also built up this so-called national steering group for AI, trying to really take and have an AI strategy for how Finland can improve their application of AI in their nation. Once again, becoming AI leading nation. All of them want to be that. We'll see what happens. In addition to that, also in April in 2018, the European Commission came out with a large report, which I had the pleasure, so to speak, of reading. But they are going to invest significantly in AI. I'm going to talk a bit more about that report specifically shortly. And then in Sweden, we have a number of initiatives as well. So we have the Wallenberg WASP program. It's a multi-billion Swedish crown program that got 1 additional Swedish billion for just improving their AI research. We have Sinuity working with Autoliv, Volvo, and self-driving cars, and they are also a multi-billion Swedish crown, not euro, program for improving the state of AI and autonomous system in Sweden. Vinnova spoke to the new general director this summer, and they are also reorganizing their organization substantially and going to have substantial efforts in being able to apply AI in a sustainable way. RISE is also someone I work quite a lot with. It's the Research Institute of Sweden, and they are about 2,200 people, now also recently restructured this summer and focusing a lot of AI. I think they have around 67 different AI projects right now and like 70 AI researchers working hard on connecting both the academia to the industry and being able to make use of AI efficiently. So it's a lot of positive signs and initiatives being done. And if we look partly on this, I don't really have time to go into details given I have only 30 minutes and I've already taken 14 of those. But if I just very briefly mention some of the highlights of the European Commission report, they're going to invest about 1.5 billion during coming years to boost the private sectors and their AI application. They're going to have some alliance, making sure we do it in an ethical and legally correct way. They are going to have some AI on-demand platform that collects and make all the AI resources available for the European companies and people. And they also speak a lot about the impact that these changes will have on the society. So a lot of talk is about the workforce and what will happen with different sectors and the job roles we have today. To briefly also talk about the Vinnova report, I was part of reviewing this as well. This is a lengthy report of about 170 pages, but they try to identify where are we today in Sweden. So they say we're really good in digitalization in Sweden, but unfortunately we are behind in AI research. And there are some sectors are of special interest for AI, but if we make correct use or massive use of AI, they claim that we have the opportunity to double the GDP in Sweden in coming 10 years if we make correct use of AI. They spoke about this UN program, the Agenda 2030, that's trying to see how can AI help the biggest challenges we have in our societies. And also thinking more, how we can concentrate our efforts in Sweden. And once again, some of the challenges we have, especially the workforce, and how that will impact the jobs we have, and perhaps create a lot of new jobs that we can see in our industry. They also spoke and mentioned, the problem of immature tooling we have today, and that is something that we need to address. We don't in Sweden have this kind of national steering group they have in Finland, so we actually took the initiative earlier this year to form what we call the Swedish Al Council, which contains representatives of different sectors, where we try to figure out how in the best way we can advise the government into accelerating the adoption of AI in Sweden. We had a meeting, the first meeting we had was in this spring, and the next week we actually saw this in the news, so the government actually took the decision to put at least 1 extra billion Swedish crown over 10 years for AI. I'm not saying it was because of what we did in the council, but I think potentially we had a small impact on that, and that would make me really happy. Okay, that was very briefly of some of the investments that has happened, surprisingly around April this year, 2018. But a lot of things are going on, so perhaps we can start to catch up if we do it the right way. But why are we seeing all these investments? So I'm going to go through a number of projects now, showing you and demonstrating what's possible to do with AI. And if I start with Peltarion, I just will want to give a quick introduction, because many of you, or is it any one of you that heard about Peltarion here before? Some people at least. But it's a startup that's actually been around since more than 10 years. And in the beginning, it was just the two founders that did a lot of consultants work. So they're really talented, and they worked with a lot of very well-known companies, such as Intel, Tesla, and NASA, and so forth. But they recognized while doing all this work that the same type of task came up all the time, and it was rather inefficient in the way AI projects were developed. So they started to develop this internal tool called Synapse that they just use for their own work to be able to more efficiently do these kind of projects. For around 1.5 years ago, when people around the world started to recognize the importance of AI, they received a significant funding from Wallenberg and Equity Ventures, saying, okay, you can see that it is possible to do tooling that significantly improves the process of building these kind of AI systems. Can we just make that at scale? So since then, we focus on building a new platform that can make it significantly easier to make use of these latest AI techniques and make that available for all, not just the large technology companies. So we are working with a set of companies, and we, for one, are working with a company called Billerud, and they produce paper pulp. And you can think of it as an assembly line or a number of steps where the pulp is being processed through this number of steps, and you can collect sensor data from those steps and try to, as early as possible, detect anomalies in that process. And if you can do that, you can more efficiently build and produce paper and increase the quality of that work. We had this other project I mentioned, and this is about identifying, you see here like a crop field, and there potentially is a disease in that crop field called wheat rust. And when that happens, it can cause significant starvation by Ethiopian people, and they don't have the sensor data there. So the idea here is to make use of data from Montana and US, where they have sensor data and we have the ground truth, and we can combine that with satellite data, and then train the model on that place and do transfer learning back to Ethiopia, and in that way be able to use only satellite data there to identify here is a potential wheat rust disease. Please go about trying to stop it as soon as possible. Another example is for doing cancer treatment. This, if you see here, is a brain picture. You can see to the left we have a large tumor in this white area. And today you have to have radiologists going through hundreds of these MRI scans, which is a really time-consuming and expensive process. But today we can rather easily build a system using these techniques that can automatically segment that area, and in that way build treatment plans for cancer patients in a much more efficient way. We have another system that tries to predict the value of houses and apartments. This is a system that is used today by the major Swedish banks. And you can take data from historical transactions for these houses, but also combine it with other types of data, such as satellite data or street view data from Google, to get an as accurate prediction of the value of a house, which the bank then can make use of to give loans in a secure way. But perhaps the project that I think is most fascinating is called Deep Weather. And what we are trying to do here is predict the energy production of a wind turbine. So you have wind turbines, and the owners of these wind turbines need to report what the production of energy will be in 24 hours in advance or up to 48 hours. And any error in that prediction results in they have to buy and sell from a spot market, and that results in additional costs of up to 4 billion Swedish crown per year. So any small improvements in prediction accuracy results in direct cost benefits for them. So the question is, can we transform this into what SMHI and what the European Weather Center, they use these simulation models to simulate the physical world, but can we transform this into a prediction problem using these AI techniques? So then we took data from satellites, we have weather stations around Sweden, we have the wind park data and more, and we put it into a model looking something like this. And one of the advantages with these kind of deep learning models is you can combine different types of data. So in the top row here, you can see data coming in here, and this is two-dimensional data, like pictures, satellite data. We can also combine that with one-dimensional data, perhaps weather station data, and we also zero-dimensional data, like scalars, data about the wind turbine or something like that. Can concatenate those and then make a prediction in the end saying, this is the energy production that a certain wind turbine will have in 48 hours. And the results looks something like this. This is actually a weather prediction. And the ground truth is the blue line. You can see the prediction from the AI model with the green line. And the red one is when using this kind of simulation approach used by traditional, like European Weather Center in this case. And hopefully you can see the green line is closer to the blue one if you squeeze your eyes, right? If we visualize this, this is a weather forecasting simulation where we have the ground truth in the bottom row. So this is really what the weather actually turned out to be in the bottom row. This is the prediction. It's 48-hour prediction. And in this column, for example, it's the wind strength in a certain direction. There is also the wind strength in another direction, and then temperature and pressure. And you see Sweden underneath, and hopefully you can see that they actually align rather well. Right? Kind of cool. So that was a couple of quick projects demonstrating what's possible to do with these techniques. I see that my time is running very quick, so I think I skipped the Spotify project unless someone really screams out loud now. But I think you all know Spotify, and they can make recommendations of music in various ways and also make use of deep learning techniques. But let me skip that and move on to some other interesting projects. And here is one of the more classical examples for an AI problem, and this is the problem of image captioning. So it's getting an image as an input, and the output should be a natural language description of that image. So for example, a man sitting on a couch with a dog. And that problem is significantly harder than just identifying that in this picture there is a dog and a person. To also from that generate a description that is, from a grammatical point of view, correct language, it's very much harder. But this is working so well today, so Facebook is using this in production. So every picture anyone uploads to Facebook today is going through a system like this and giving a textual description for people, for example, that are visually impaired. Perhaps the most classical AI problem of all is doing machine translation. Today, we have come far away from the Georgetown experiment. So it's not only 60 sentences, and it's not just 2 languages, but we can take more or less any sentence and translate to any other of 100+ different languages. It's not human quality yet. Some of the translations is not perfect, but it's getting very close. And it's not only it can make a translation, it can take a picture, extract the text from it, do the translation, and then replace that text in the same image, which is actually a very difficult thing to do, but works surprisingly well. I went to a conference once, and Amazon spoke a bit how they make use of robots, and they are probably the one that makes use of most of them. They say they have 100,000 robots today. The robots are these small orange kind of things that drive around these pallets of different products throughout the warehouse. And they said, I think, an interesting and a telling statement, which is, even though they have built 100,000 robots and they have 300,000 employees, no human was ever fired because of the robots. Instead, they say, the robots actually empower the human by becoming 30 times more productive. And I think this is a really good, insightful comment, and the most probable way that we will see our society in coming 5-10 years. AI empowers human. But AI doesn't always work. Let's take a couple of seconds to watch this video. This is from the DARPA annual robotics challenge in 2015. And the robots are given certain tasks, like going from point A to point B. That's hard enough sometimes. Or opening a door. Walking up a set of stairs. This one is going to try to turn this red valve to the left and open the valve. This one was almost right. It's just 1 decimeter to the left, so... So let me quickly pause here, and this is the last example, but I want to give a background about this. So this robot has done something amazing. He went into this car, far back in this route. He drove the car. He has now come to the finish point, and the only task left is to exit the car into this yellow square. He actually scored some points for completing that task. I had this as well. Yeah, this is actually one of my favorite examples. The other examples you saw is from companies that have big research groups, etc. This is the opposite. This is a small family farm in Japan, and the engineer went back to the family to try to help out with a cucumber farm. And they want to categorize these cucumbers into 9 different categories. And he took a more or less, standard Kira's tutorial example of how to do deep learning, put in a web camera, and were able to build a system in a really small scale that still was able to categorize these cucumbers. This is what we want, to have people being able to use these techniques without having huge research groups. I think I'll skip this one. How many here has heard about Google Duplex? Okay, so this is a really cool thing. It was launched earlier this year. It's not really launched to everyone yet, but it takes basically orders. So you have text as input. You do a speech recognition from that. You get some kind of context. You want to have a dialogue system, so you can give answers to questions depending on what you said before. and then you get some text as output, and you want to do text-to-speech back to voice. And then it can sound like something like this.
Let me give you another example. Let's say you want to call a restaurant, but maybe it's a small restaurant which is not easily available to book online. The call actually goes a bit differently than expected. So take a listen.
How may I help you?
That was the human at the restaurant.
I'd like
this
to
is a machine.
for Wednesday the 7th.
For 7 people?
Human.
It's for 4 people.
4 people when? Today?
Next Wednesday at 6 p.m.
Oh, actually we reserve for like upper like 5 people. For 4 people you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
You may not think that is impressive, but I think it's super impressive. Not only you can do this kind of discussion, dialogue system in real time, but also have a way of talking which is really natural, doing like, gotcha, which is very non-robot type of speech. So, okay, let me end by just giving a final example from Peltarion. And this is where we want to do a rather different type of AI problem. We want to learn a machine to dance. So we had a professional dancer taking motion capture data from that dancer and then feeding it into a deep learning model and training it on a cluster. And when training it for only 10 minutes, the machine generates dance looking like this, which is not very impressive. But look what happens after 2 days of training. And to make you understand what's happening here, it's not like they're making predictions one by one. It's actually generating new dance moves all the time that never been seen before. It's not memorizing the professional human dancer. It's actually doing machine dance that is in similar style as the human. So imagine, if we can do all this today, imagine what we can do in 5 years. We should not understate, the problem of building these kind of systems. It is actually more problematic than you think. And that's why the big tech companies can do this, but it's really hard for most other companies. So there are problems with the tooling, it's too immature, but we're also seeing this kind of explosion in different network architectures. So we need some better help with that, and that is precisely what we're trying to do at Peltarion, to make these kind of techniques available for all, not just the big tech companies. And given all the investment we are seeing, I think it's awesome that we are seeing these investments, and Europe and Sweden are trying to catch up. We have a rather fragmented situation in Sweden today and in Europe, but if we actually do this in a coordinated fashion, and also take advantage of some other problem that exists, data safety and privacy that we've seen some problems with, if we actually take that as an advantage, we can actually be leading this area in Sweden and Europe. And if we do that in a coordinated fashion, we can actually be looking at a really beautiful future where we maximize the benefits of AI in our society. With that, I thank you for your attention.